Let me introduce to you two of the more special addresses. The special address is. It has other uses. The first one is 0.0.0.0. You have to remember. This is 40s. This address is not available. Not only 4 zeros are not available. From 0.0.0.0 to 0.0.0.255. You can't configure. Because it has other functions. At the routing level. It represents all addresses in the whole network. Can also be understood as any address. For example. In the future. You are going to access the internet. If you are going to visit various websites in the future. Then every URL you visit. The destinations are actually all different. Any business we visit. It's actually an internet business. It's the operator's business. As long as you are online. In fact. It is the operator's network. Then you just need to hand the traffic to it. It's just to help us forward. That is. You don't need to care where exactly you're visiting. As soon as you receive a data. Now use the public network to directly forward traffic to them. So now for all this traffic. We can use 4 zeros to represent. That is to say. We use 4 zeros to replace all addresses on the entire network. It is also called a default route. Second. It has another function. It also represents an address called unspecified. I'll just tell you this. Because we can't get in touch now. In the future you will be in the stage of NP. Learn a protocol. DHCP. We now turn on the equipment. Configuring IP addresses on the internet. For example. Now for my network card. I'm on wireless now. Everyone can see. I now want to surf the internet on this device. So you need an address. Then I am not manually configuring this address by myself. Is obtained automatically. In fact. The device is now running a protocol. DHCP. I do dynamic host configuration. For us. There is a DHCP server in our company. Come and configure the IP address for me. Then, during the entire configuration interaction process. When the device runs this protocol with a server. I want it to give me the address. I have to send a package to tell it first. Communication of what we call data. In fact. The point is that the data comes and goes. I want to request some business. Request some parameters. I can send it in the form of a message. Like communicating with people. Device-to-device communication can only send messages. Then when I request the address. Need to package. Data is encapsulated. For data communication. The parameters of each layer must be encapsulated. Even if you don't know. Also fill in a don't know. This field cannot be left blank. For the link. Packets are actually bit streams. It's actually what we call an electrical signal. High and low frequency is the electrical signal transmitted. If fiber is used in the future. It transmits light signals. The data transmitted by the refraction of light inside. After being compiled by the network card. It becomes 0101. When you learn NP in the future. We'll learn something. Port mirroring. When you are in the project. When actually capturing packets. You can use port mirroring. Get the real message. For example. Now this is a device. There are multiple interfaces on the device. For the interface. It always transmits electrical signals to the outside world. Then we can use another port. To enable port mirroring. You can capture the data that is actually sent so far. In the future. We are in the process of experimental configuration. I can show you. For running such a protocol. The first time you request an address from the outside world. Package address. Since you don't have an IP configured now, so you don't know what IP you are, you'll go with 4 zeros. Okay. This is the first special address. 4 zeros although belong to Class A address, but cannot configure. This is rather special. The second special one is 127.0.0.0. It refers to the entire network segment of 127 has been extended to 127.255.255.255. It's called a loopback address. We all know 127 is for testing. For example, test the network card is not bad, or the test network is not working. If you think there is something wrong with the device right now, there may be a problem with the internet. If you want to test now, everyone will choose to open CMD to ping Google. Won't open CMD to ping a 127. This means that we routinely test network connectivity. In fact, there are many reasons for the failure of the real network card. Why we ping Google? Just want to see if Google will give me back the package now. I want to see if I can access the internet now. That's for 127. It is used to test the TCP/IP protocol station inside the device. I believe that everyone must not understand. Let's go back to the picture we just made. You can see an internet here. Write a TCP/IPv4 behind. This is a protocol station that has been integrated on the device now. I told you in the last class. The network communication model we are actually using now is a model like TCP/IP. Why we talk about OSI? Because it is more clearly divided into layers. Actually, although it is clearly divided into levels. However, due to the inexperience of this organization, not many protocols have been developed. An organizational framework that supports it. And for TCP/IP, it actually has a longer history. Developed earlier. And for every layer of internet communication, it has developed a corresponding agreement for. So, that's why we use TCP/IP now. What we see now is this TCP/IPv4. This is the device itself that comes with the Windows system later, or called an integrated protocol. This protocol does not require you to manually install. But in the early days of the internet there were a lot of protocols. For example, Apple Talk, IPX and more. If you want to install such a protocol at that time, after the installation is complete, you need to test whether the installation is successful. Ping 127.0.0.1. If the ping is successful, it means the test is complete. Because only TCP/IPv4 can recognize such an address. If we fully use TCP/IPv6 in the future, that is, V6 doesn't know the address of V4 at all. Device is not recognized. If you install an IPX protocol, overall its address will be longer. Will be longer than an IPv4 address. Although it is compiled, it is also 0101. But their final representation, not dotted decimal, not 4 groups. If you install the IPX protocol, then you go to ping this address. Even if you call up the CMD command line, you use this ping. First of all, it doesn't know what ping is. Second, you ping an address like this. Definitely can't ping. Because this address does not conform to the protocol specification at all. It cannot be read. So you can see that there is an installation here. Click to install. Here is an option for a protocol. Can choose. You can click to add. But it's gone now. This is something we rarely use. But for the early, we will still install the protocol station manually. Because there is only one protocol station in the world now. No need to install. Because a network device is bought by default. Just to communicate. You can only choose this one if you want to communicate. Because all network devices only support TCP/IP. So now, by default, we also don't need to install any protocol. The difference between v4 and v6 is that the first point is the address space. IPv4 is 32-bit. IPv6 is 128 bits. IPv6 headers are more compact. Takes up less space. Implemented more functions. Made a comprehensive expansion on the entire IPv4. In fact, the first problem to be solved is the number of addresses. In the future, if it can fully migrate to the state of IPv6. In fact, there is no distinction between public and private networks. This concept we will discuss next. Then will be a lot easier than we are now. This is only from the address direction. Second, due to the overall scalability of IPv6, it's in a lot of future features. More support than IPv4. Including IPv6+ in recent years. SRv6. This is the future trend. Due to the rapid advancement of IPv6 technology. So in recent years, IPv6 has been mentioned more and more. But in fact IPv6 has been around for a long time. But in recent years, the demand for it has become more and more strong. The above is to test the TCP/IP protocol station. When you have installed TCP/IPv4, you go to ping 127. No matter which address on the 127 network segment you are pinging. Ping from point 1 all the way back. Can be pinged. It tests the underlying protocol. So you will find, although the ABC class address can now be configured, but actually there aren't that many addresses available. Class A addresses are available from 1 to 126. You need to remember this. Okay. Let's go on. We have already divided the three types of ABC addresses. Well, I now have a new question. If I were to now have access to all the devices in the world, assign an address. According to reason, everyone must have an IP. Because if there is no IP, data packets cannot be encapsulated. Can't get online. Internet access with IP. Every device that wants to access the internet must have an IP. Then please. These IP addresses we now call. Is it enough to give each person one? Okay. Definitely not enough. First we need to know. The IP address is 32 bits in total. 32 bits have two variations for each bit. A total of about 4.294 billion changes. Then think about it. Is it enough to distribute to the whole world? We don't have only one mobile phone to surf the internet now. Generally speaking. Working. At least one laptop for office. Play games at home with a desktop computer. You have a computer. A cell phone. And a tablet. Each of your parents has a cell phone. Suppose there are 5 people in a family. Will occupy almost 10 addresses. Including at home and now. Smart speakers or smart sweeping robots. Or the TV can also be connected to the internet. All these addresses add up. I believe you can imagine how many. For netizens all over the world. One address per person is definitely not enough. According to our logic. Wouldn't this collapse? If you want to go online, you need an address. Not enough addresses. How did you get on the internet? So there must be a way to fix it. That for the entire address design. We envisage. Because there may not be enough addresses. Therefore, in the overall address classification, we have divided into 2 categories. They are called private address and public address respectively. That is, based on application, split into public and private networks. So let's first talk about the public address. We want to communicate on the internet. All addresses under the public network when communicating must be unique. For example, your company is now running a business. Then your company is on the whole network. Is the only device that needs to be able to locate you. Your company has an export facility. Like Google. Google has a server. Then you want to access Google's server. It can't be said that the Google server has a duplicate IP address with another place. When you visit, who among them was visited? Also unknown. So we face the public network. We want all addresses. Must be unique. The public address has such uniqueness. I can access the entire network. That is, in the internet as a whole. I can only locate your device. Its uniqueness is based on worldwide uniqueness. That is to say, worldwide. It is guaranteed to be unique. But usually, you have to pay for this stuff. You need to spend money to find the operator to handle the corresponding service. Then the corresponding public address will be given to you. So we will know. Due to too few addresses. So it is impossible to guarantee. Every device in the world. Every interface. Use a public network. Definitely not enough. Suppose your company has 100 people. Need to apply for 100 official website addresses. For the time being. Let's not say whether the address is enough or not. The cost is already very high. Because it costs money. So, now we are going online. What each end user actually uses. Not a real public address. Instead use a private address. It is actually from the overall address space. Cut out a small piece. As a private address. Private address and public address are relative. It's not the only. This means that all network-wide can be used arbitrarily. It is free. And you don't need to apply. It is reusable. This is called a private address. Now above this is the operator. Below is the carrier's network. Services it provides us with access to. There are also many devices in the operator. And they are also connected. The address they use is the public address. Because operators want to provide mutual access services around the world. That is to say, all forwarding addresses on the public internet must be determined. Can uniquely locate the next device. Because you have to keep querying the next device. Forward. It is absolutely impossible to appear in the middle. Two addresses are the same. Certainly. It's not absolute. Later you will find out. It's not as simple as what we're learning now. But you can understand this now. Public network. The operator's network is the public address. Of course it also has a private network. But the specific operation and enterprise network are not a set of operation model. Therefore, there will be a special technical direction in the future. Is operator technology. Then you will find. It is not a technical system with the enterprise network. So for us now. You can remember this. The above is the public network. Then export this device. When docking with operator equipment. This address must also be a public address. Because the company's people are going out to the internet. Then the package needs to be returned to the device. Otherwise there is nowhere to find the message. I can't pack it back. So it has to be a public network too. But for the following. Such a network range. There are multiple users inside. Then these users can use the private address. This is the address that every company can use. The future is exporting here. It will do a conversion between the private network and the public network. Now only guarantee. This private address is not repeated internally. Because now there is internal communication. Can't share the same name with other people. But in the future when we export, A technique called NAT can be used. Put this through a conversion. Convert this private address to a public address. Then go out and go online. After the network finally responded. Then configure the NAT device by this. Convert this address to a private address. That is to say, this is equivalent to the internal and external network. It's two completely different systems. We can use private addresses internally. When people are online, transfer to an external public network together. Then it goes to the public network. So then, since every unit, every organization and institution can be used internally, but it won't repeat. For example, we can all use 192.168.1.1. Every household has this address. Why not repeat? Because when we finally access the public network, the converted address is a public address. It will not repeat. But within each organization, the private address used is randomly repeated. Because they do not communicate. Even if there is a need for mutual visits in the future. That is also the demand from the public network to the public network. Because only the final data traffic reached the peer device. It only knows that the NAT is going down now. Actually, we all access the public network from the public network. That's how we look. At least from the looks of it. Then inside, we do such a conversion between technologies. Unlimited things can be done with limited addresses. You will find that your company originally 100 people occupy 100 addresses alone. It's different now. Can now be allocated 100 addresses available to all companies. Equivalent to the end user problem solved. We only need to ensure that the current public address, when the user comes out, it can be converted smoothly. What we actually use now. Such a technology. If the current Google address is 7.7.7.7, it has a mask that is 24 bits. Then can I configure a 7.7.7.7 for the internal device now? Okay. This address is configurable. The reasons are as follows. First, it conforms to the configuration specification for IP addresses. It must be connected to the device interface. Second, for example, you assign 0.6 to the one on the left. This is 0.5. This gateway is 0.1. 7.7.7.1. There is no problem with communication between you. If the current public address is 123.11.2.3, there is no problem. After you have allocated this address now, it will be a rather embarrassing thing. Due to your current address and Google's address. Then when you encapsulate the data, by default, it will consider this to be an address on the same network segment. How are you sending the package now? The source IP is yourself. The destination IP is also your own. The source IP is the same as the destination IP. This message is in terms of the entire communication format. Is not possible. That is, I want to send myself a package. Then the default package will not send out the interface of this device. Because once this interface is assigned an address, that is, once configured with 7.7.7.7, a message will appear on your device. 32-bit host routing. Generated on your device. Because the device thinks this is you. To visit yourself. So it will not outsource. This is the first question. The second question is, if your address is weighted, does not affect the internal communication between you and others. Intranet is accessible. But this 7.7.7.6 on the left, when it wants to visit, source IP is self. The destination IP is 7.7.7.7. It wants to access Google. But since now when visiting, this device is computed locally, we will find that this person is on the same network segment as me. It thinks we're both on the same network, so it is directly communicated internally. It will send the data directly to you. It doesn't know I'm going to visit Google now, because I am on the same network segment as Google. I thought we were on the same network, on a logical link. I'll just send it to Google. Google got it. That for you now. I can't go online. But that's not to say it's absolutely impossible. If now Google is not 7.7, it is 11.1.1.1. This is also a public address. But you are still using 7.7. That's fine. Such a public address can still be used internally. Now everyone can communicate with it. Because of the exit, this will convert the address to 123 of the exit. It's okay. But make sure, internally, if a public address is configured, you have no way to access the future URLs on the same network segment as you. That is, address conflict URL. Second, all other equipment. As long as there is a need to access the outside world, then it is inaccessible. You can configure, but you can't guarantee. Will this configuration affect other people's internet access? Because we are online now, DNS is used. We are all analyzing. You don't even know the destination server you are accessing now. Which network segment does it belong to? You can't promise yourself not to repeat it. That's why we can configure it. Can also pass. But why it is not recommended to do so? Some students will ask. Why does the configuration of the private network not repeat? Because it is absolutely impossible for a private IP to appear on the public network. That's why it made this painting a private network. It is specially designed for you to configure in the private network. Can guarantee you absolutely access to the public network. There is no problem. Because it can guarantee. There is absolutely no device on the public network that will configure a private address. You can configure it like this. Then the DNS needs to be changed accordingly. Because for internet devices, just such an address. First, make sure other devices can't think the server is you. Second, for external devices, except in your internet, no one knows you are at this address. So can you configure this? It doesn't matter to the outside world. You just have to guarantee. There is no internal conflict. Because to the outside world, now this is an internal. No one cares who this is. In the end we are all going to perform NAT. That is, when we connect to the carrier, one address is enough. It can meet the current needs of internal internet access. Then for the private address, it has a stipulation. That is, range of private addresses. Everyone will find. I am from the ABC 3 types of addresses. Cut out a piece. As private address. Everyone can see. First of all, the first one belongs to the Class A address. From 0 to 127. The second is to cut out a block in the B class address. Because Class B addresses are from 128 to 191. It is 172. And a block is also cut out from the Class C address. In fact, these 3 types of private addresses, it is possible to distinguish small, medium, and large corporations. Generally for small businesses, Class C address segment is sufficient. For medium-sized companies, if Class C is not enough, use it together with Class B and Class C. Large enterprises directly use Category A. You will find it more variable in number. Class C address segment can be changed to a smaller range by default. So let's summarize the 3 types of ABC addresses. looks like we can all use. But actually on the internet. That is, when we are going to network. We really have a unique IP address on the public network. You want to remove the special address. And remove the private address. Because private addresses are generally used by internet users. Not available on public internet. So you have to rule out the private address. The rest is what can really be configured on the interface. Unique IP address. Next we have to mention another concept. Subnet mask. For the IP address we just talked about. The following is suffixed with a subnet mask. Why is there such a suffix? Everyone can see. When I was showing the network card just now. This IP address has a subnet mask under it. There is a correspondence between them. Let's see how they look first. The first to discover. They seem to be similar. Both are dotted decimal. So let me ask you a question now. For example. Now there are two devices. Each device is configured with an IP. Can they communicate? For example. This device is configured with 192.168.2.3. Another device configuration 192.168. 1.2. Can they communicate directly? Okay. It depends on the mask. You want to know if you can get through. You can't tell just by looking at the address. We have to combine another parameter. Mask. Because it is possible to communicate directly. This is to have a network segment division. You may have heard a sentence. Direct communication on the same network segment. Different network segments cannot communicate directly. So we can't just look at the address. Let's look at the network segment. So we have to combine another parameter. Subnet mask. Only after combining the subnet mask. The classification of IP addresses has the greatest significance. It can constitute all the information used on a real network card. After IP address classification, 3 ABCs actually define different address ranges. That is, subnet mask. Then I will add to you. For class ABC. In addition to defining their current value. They also define their respective masks. The mask of class A is 255.0.0.0. That is to say, class A address defaults to a 8-bit mask. That's the same for the BC class. The class B address mask is 255.255.0.0. It defaults to a 16-bit mask. The class C address mask is 255.255.255.0. It defaults to a 24-bit mask. This is the default. I will give you a simple demonstration. For example, I'm going to be on my NIC now. Go configure it. This address is supposed to be automatically assigned. I now want to manually write an address to it. Let's first write a class A. For class A, we will write according to the private address. Now let's say we're configuring the address right now. I am writing a 10.1.1.1 here now. Watch carefully. I do not configure the mask. Just hit the tab key. Make it wrap. Everyone will find. It automatically adds 255.0.0.0. Because what I'm writing now is a class A address. Although it is a private address. But it automatically writes me a mask. For example, I write a class B address. 172.16.1.10. Hit the tab key and you will find. I have to delete this first. Everyone can see. It automatically fills me with 2255. I will now write another class C address. 192.168.1.12. Let's not click OK now. Because I don't have a gateway configured right now. If I now change the overall address and gateway. I'm disconnected now. Because I am using a default assigned address. And after I change the address, may conflict with other equipment in the company. After I hit the tab key now, everyone will see 3 255s are now filled by default. This is equivalent to, for such an address, our equipment will automatically identify which address range it belongs to. It stands to reason. This 192.168.0.02, 192.168.255.255. By default it belongs to the address range of class C. And the mask is 24 bits. Then when you configure a class C address on the device, it will automatically match your mask. We call it classed. It is divided into ABC3 categories. So for the address, it must be seen in conjunction with the mask to make sense. The subnet mask can define two parameters. It can define parameters of network bits and host bit parameters. This is what it does. We use a form of IP address plus mask. You can define a range of network segments. Then after defining the network segment, direct communication between the same network segment. No direct communication between different network segments. How to define it?